I'm going to turn the record of this meeting on, and then I have the ability to write whatever I want to. Let me write something. Can you read that number?
7.
Yeah, okay. So you're reading my screen. Now, the way this kind of works is that I ask you to give me the problems. I will write them out on this screen, and then we'll go to solving them.
Okay.
Okay. You are a PreCalc student, is that right?
Yeah.
What grade are you?
I'm in 11th.
11th, junior, okay. And is it PreCalc Trig or just PreCalc or?
It's just PreCalc.
Okay. Do you have some problems we can practice on?
We're doing transformations of functions right now.
Okay. If you want to
So
read,
it's like,
if you want to read one of those, I'll write it down and you'll get a good idea how this works.
okay, so f of x equals negative square root of f minus x squared.
Of f?
No, 4 minus x squared.
4, okay. Like that?
Yeah, and then we have to find the domain, range, and graph it.
Okay. But they're not asking you to tell them the transformation?
No, that too, yeah.
That also? Okay. Because this is kind of a tough one to start with regards to transformations. I can do it, but it might be a little confusing. It might be a little easier if we started with an easier one. And I'll explain. Well, let's go ahead and do this one. I just hate to start out with this hard of a problem. So what is the parent function?
X squared.
Square root of x. Ah, interesting. They gave you a really tough one. Let me think about this for a second. Well, let's talk about the domain. And then we'll get around to figuring out the transformation. What is the domain and how am I going to figure it out?
Well, you know that a square root, you can have a 0 underneath it.
But you can't have negative numbers, right?
Yeah.
Okay. So what that basically means is that whatever's under the radical sign has to be greater than or equal to 0. Can be equal to 0, and it can be positive, but it cannot be negative. So now we need to solve that. So can you solve that inequality?
Wait, what did you say? X is greater than or equal to 0?
No, what's under the do I have what's under the radical correct? Is it 4 minus x or 4 minus x squared?
4 minus x squared.
Okay, so that's what's inside the radical. It does not matter how complicated it is. Whatever's inside the radical has to be greater than or equal to 0.
Okay.
Okay, now do you know how to solve that?
Yeah, I'm doing it now.
Yeah.
Radical 4, so it's...
Well, x has got to be less than or equal to 2. And greater than or greater than infinity. No, greater than Let's see. Could x be 1? Yes. Could x be negative 1? Yes. So x can be negative, so it's just got to be greater than negative infinity. Something's wrong there. Hold on a second. Let me think about this for a second. That's why I say this is a particularly tough one to do. Let's just go ahead and try to solve that inequality. So we get 4 is greater than or equal to x squared. And now you get x is less than or equal to 2. But it also has to be less or greater than or equal to minus 2. So when x is between minus 2 and 2, you're fine. If x were minus 3, it's not going to work. And if x were positive 3, it's not going to work. So x has to be in that interval right there. You see that?
Yeah.
In other words, like I said, if we pick a point minus 3, we end up taking the square root of a negative number. If we take a point to the right of 2, like positive 3, we also end up taking the square root of a negative number. So we've got our domain. Do you know how to put that domain in interval notation?
Yes, it'd be like a bracket or a parentheses.
Yeah, you're right. It is a bracket because it can be equal to minus 2 or 2.
Yes, negative 2, 2.
Okay, so that's our domain. That's what x is restricted to. Now, let's talk about the range. The range is all of the possible f of x values. In other words, the range refers to the y, the domain refers to the x. What is f of x going to be? What are all of the possible answers for f of x? Or what can f of x not be? We know that has to be either 0 or positive, correct? So this is going to go from negative infinity to 0. Notice that there is no way that the range can be a positive number because of this right here. First of all, everything that comes out of that radical has to either be 0 or greater than 0, right?
Yeah.
The square root of something, it's always positive or 0. So when we add the negative sign, it means that we can go from 0 to negative infinity, or if written properly in interval notation, it's negative infinity to 0.
Yeah, okay.
Okay. So what was the third thing besides domain and range? Graph it?
Graph it and then find the transformations.
Okay. This is a bit of a strange one because this does not appear to me to be a transformation of an elementary function. I'm going to erase all of this stuff so I got room to write. Now, are you allowed to use your calculator? Do you have a graphing calculator?
Yeah, but We haven't used it in class yet. She said to just do it
You're supposed to
without.
be able to do this as a transformation.
Yeah.
Now, if this was something like this, that's easy. That represents a reflection over the x-axis. That represents a horizontal shift by 2 units to the left, and the parent function is square root of x.
Yeah.
Okay, you follow all that?
Yeah.
Well, this particular problem you gave me, what is the parent function?
X squared. Or would the square root cancel it? That's what I'm confused about.
Well, I'm confused about it too. I've never gotten this kind of a problem. This does not look like a straight transformation problem to me. How else could we write that? We could write it as 2 minus x times 2 plus x. In other words, that's the true statement.
Mm-hmm.
But we still don't have a simple transformation. Let's do something here. Are you familiar with Wolfram Alpha?
No.
Let me open it up and show it to you. And it is an excellent internet site for mathematical problems. Okay. And I can go on here, and this is basically a graphing calculator also. So I can say y equals negative 4 minus x squared raised to the 1/2. And it will tell me what I put in. That's what I love about this. In other words, I put in the correct thing. Can you see what it shows you the input? What kind of graphing calculator do you use, Subby?
I used the TI-84.
Okay. On the TI-84, you can put it in like I put it in, but it doesn't show you what you put in. So Wolfram Alpha is a little bit better for that purpose. Ah, now I get it. Notice what it says this is.
A circle.
Huh. So that's what I didn't notice the first time. Let's go back and talk about this. So we had, hold on a second. All right, if we make that say y, and we square both sides, what do we get?
Like you square the negative as well.
Yeah,
You
in
cancel
other
the
words, if
square
you're going
root.
to square both sides, you got to do that.
You cancel the square root.
Yep. So you're left with that.
Yeah.
When I turn that into this, that is the general equation of a circle, whose center is at the origin and whose radius is 2. In other words, the general equation of a circle is this. Are you familiar with that?
Yeah.
Okay. And r is the radius. So r squared in this case is 4. H and k are both 0, meaning that this circle has its center at the origin. And it is not a transformation of any elementary function. It is the equation of a circle. So this really is not a transformation problem.
So wait, how do you know that the origin is at 0, 0? Like, how do you know it's not anywhere else?
Because h and k are 0. Because I'm looking at x, actually I'm looking at x squared plus y squared equals 4. So h is 0, k is 0, and that is the coordinates of the center. So that's
Okay.
how you know. If it was x minus 3 squared plus y minus 2 squared equals 4, then on my circle would be, it would have its center at 3, 2. And I would have a circle about that point with a radius of 2.
Mm-hmm.
So that's how you know.
Okay.
Okay? But yeah, the problem here is recognizing that that is the equation of a circle. It's just, in other words, you have to square both sides in order to see it, but at least I did. But once you square both sides, you get this, which is clearly the equation of a circle, and that is not an elementary function that has been translated or transformed.
Okay.
Ah, there's something else about this. Okay, hold on a second. Let's just go back to the beginning here. Let's take a simple circle. And if I solve that for y, you with me?
Yeah.
That is the equation of a circle. And the plus or minus is important. The plus is that side. The minus is this side. So you end up with a circle, but only because this is a composite function. It is not a function. Notice that a circle does not pass the vertical line test. So a circle itself is not a function. It's a relation. Okay?
Okay.
But it happens to be the composite of two different functions. The blue is a function and the red is a function. And that is the entire circle. So they asked us what that is. Well, that's just the negative side of it. So the actual graph, I was mistaken the first time I did this, the actual graph is that blue right there, and that is a function. It's not a transformation of a function, but it is a function. And
So it's a semicircle?
I'm sorry, what?
So it's just a semicircle, that's the graph that we're supposed to
Yeah,
draw?
exactly. And this kind of points out that we made a mistake. Our domain is indeed between 2 and minus 2. Because there's 2, there's minus 2. But our range only goes down to minus 2, never below. So our range only goes from minus 2 to 0. So the range is like that. It can be minus 2 and it can be 0. So this is the range. I'm not sure how I ended up getting the other one. I guess because by virtue of the fact that I didn't recognize it as a circle, I was a bit stumped. But now that I see it's a circle, or half of a circle, we're in good shape. And this is not a transformation, so that should not be a question on this function. Well, it's not a function, actually. Well, this is a function. The equation of a circle is not a function. But as long as I put the negative sign out in front of that radical, then I'm only referring to the lower half of that circle.
Okay.
If I wanted to refer to the upper half, I would make that negative sign a positive sign, and I would get the other half of that circle, this half. So we can certainly figure out the domain and the range, and we can graph it. It's just the blue graph, but it does have a closed dot right there, and it's just the blue graph. But this is not a transformation of any elementary function.
Yeah, I don't know. It's labeled transformations of functions, so that's what I thought.
Yeah. First of all, let's talk about transformations. Are you covering transformations?
Yeah.
Okay, here's your basic functions. There's like 10 of them. I can take any of these functions and transform them. In other words, if I told you that y equals square root of x minus 2, that is a transformation of that.
Yeah, 2 units to the right.
Since the 2 is inside the function, it is a horizontal transformation. Since the 2 is being subtracted, it is a horizontal shift, and it's a shift to the right by 2 units. Whereas here is y equals square root of x, over here is y equals square root of x minus 2. So that's the way transformations work. You have to be able to add or subtract or multiply or put a negative sign in there for a reflection from your elementary function. But notice what you gave me, square root of 4 minus x squared, is not any kind of transformation of an elementary function, not of x squared and not of square root of x. It's a composite function, is what it is. Although actually the one you gave me is a pure function because of the negative sign. It's only the lower half of that circle. It's not the entire circle. Why don't you give me another one, and maybe we can straighten out what's going on here.
Okay. F of x equals 1 over the square root of x plus 3.
Like that?
No, the plus 3 is outside of the fraction.
Okay.
It's just rad x under the fraction.
Yeah. Like that. Still in the denominator or outside of the fraction?
No, it's outside.
Okay.
It's like its own, and it's plus 3, not minus.
Like this?
Yeah.
Okay. Well, this would appear to be hyperbolic in nature. That, incidentally, is another elementary function, this right here, which graphs like this. However, again, this does not appear to be a transformation of that. because we have the square root of x in the denominator. So let's not treat it as a transformation problem, because I don't believe it is, but we can still answer the questions. The domain. What can x not be?
It cannot be a negative number or 0.
Okay, so the domain is what?
It has to be greater than or equal to 0. X is greater than or equal to 0.
Right there? Interval notation?
Yeah.
And it's a parentheses, not a bracket next to the 0. Because x cannot be 0 in this case because you can't divide by 0. Okay. The range. Now this is a little tricky. What's the lowest that could be?
1.
What if x were a billion? That thing's going to approach 0, correct?
Yeah.
What if x were infinity?
It'd be close to 0.
Yeah. So the minimum value that this thing can possibly have, because this thing that I've circled can never be negative. It can only be positive, and it can approach 0. So the minimum range is 3 to infinity. Notice that if x were a number between 0 and 1, like a half, well, I got 1 over a quarter, so that's 4 plus 3. So the closer x gets to be 0, the bigger the circled part gets. So the range definitely can go up to infinity. But it can never go below 3 because this part right here, not the square root of x, but the whole thing that I have circled, that whole thing has to be greater than 0. There's no way to make it less than 0. There's no real way to make it 0 other than making x go to infinity, which is getting into limits, which you probably haven't had yet. Have you had limits?
No.
Okay. So there's no way to make it exactly 3, because then I would require the circle part to be 0, and there's no value of x I can put in there to make that 0. It's always going to be some positive number. Okay? So it can come close to 3, but it can never be 3. So therefore the parentheses. And like I said, to make f of x big, is all you have to do is try an x of 1/10. And notice that if I put an x of 1/10 in there, the square root of 1/10 is 1/100th. So now the part that I have circled is 100. So I can make this thing get big by just making x get close to 0. Okay. Now, how do we graph this thing? I'm going to go to Wolfram Alpha, and I'm just going to put in y equals, first of all, if I put in y equal 1 over x, you'll see that that is the basic function. Hyperbolic in nature. That thing can be translated, okay? But we don't need to yet. But now let's put in 1 over the square root of x. Hold on. Again, notice it shows me what I put in, and it only gives me the upper right quadrant of that hyperbolic function. You with me?
Yeah.
What's going to happen when I add 3 to this?
You're going to move it up 3.
Yeah, and that's all. In other words, this line, can you see where I'm pointing here?
Mm-hmm.
That line is going to go up by 3 units. So let's see what happens when I add 3 to that. Again, it's going to show me what I put in, which is really nice. And you can see that it took the same exact curve, didn't change its shape at all, just moved it up 3, so that it's now going to a horizontal asymptote of 4.
Mm-hmm.
Whereas the other one had a horizontal asymptote of 1. In other words, just 1 over square root of x. But again, 1 over square root of x is not an elementary function, meaning we can't, I guess we can. It is a function, I suppose. It's not one of the 10 that they start off teaching you. First of all, transformations there's only 6 kinds of transformations. There are reflections, both vertical and horizontal. There are shifts, horizontal and vertical. And there are stretches, horizontal and vertical. That's it. There's no taking the square root of something as a transformation.
Mm-hmm.
So if my elementary function was 1 over x, I don't really have any way to transform it into 1 over square root of x. 1 over square root of x is its own function. Now, maybe your teacher is calling that an elementary function, and I guess you could. I suppose that is an elementary function. And by adding 3, we're merely doing a vertical shift. So if you want to think of it that way, that's a good way to think of it.
My teacher gave me a packet with all the parent functions on it.
Oh, good.
And yeah, the function that we're talking about with 1 over square root of x isn't on it.
It's
so
not on it, or it is?
Yeah, no, it's not on it.
Yeah, I've never seen that as an elementary function, to be honest with you.
Yeah, I don't think it is one. So
Okay. Yet we can still transform it. In other words, by adding 3, it didn't change the shape of 1 over root x.
But how do you know how to graph 1 over square root x in the beginning before you do the transformation of plus 3?
Well, that's a good question. If it's not what you should know is how to graph all your elementary functions, all your parent functions. That's what you want to memorize. And most functions that you come up against are going to be transformations of an elementary function. Let me just write here just to explain. Hold on a moment. In other words, if I have an elementary function like this, well, I can transform that a lot. That would be a translation of it. That would be a vertical reflection. This would be a translation of it. That would be a vertical shift. This would be a translation of it. That would be a horizontal shift to the right of 2 units. But this is not a translation of it. That's its own function. Now, I guess one could call that an elementary function. And we've seen how it graphs. It graphs like a hyperbola, like that.
Mm-hmm.
So now, if you want to call that an elementary function, seems like we could do that. Now, if I want to do things like that, that moves it up by 3. If I want to do things like that, that takes this function that I have right here and moves it to the right by 3. If I want to do that, that takes that function, reflects it over the x-axis, so I end up with that. But you have to be able to graph the elementary function. And the fact that they only, how many are on the list that your teacher gave you? How many parent functions?
There's a lot. Wait.
Are there 10?
There's 15.
There's 15. Okay.
There's one of them, like f of x equals 1 over x squared. And it's the same kind of the graph that you showed me with 1 over the square root of x, except it has on both sides.
It's like that.
Yeah. So is it like if you take the square root of the x, you only get 1/2 of it? Because like you said in the other one with the circle, there's like a plus and minus.
Yeah. This is a little different. In other words, in this particular case, the left side of the graph is when x is negative, but 1 over x squared, it doesn't matter whether x is positive or negative, it gives you the same answer, correct?
Mm-hmm.
So this part of the graph is going to be the same looking as that, it's merely going to be a reflection. And so I know how to graph that. Well, that's because this is a very common function in calculus. So there's no necessary convention that says there's only 10 parent functions, okay? Obviously, if you have a list that's there, you got 15 of them, there's at least 15 parent functions. But I presume this is not one of them on your list.
Yeah, no, it's not.
Okay. That doesn't mean we can't graph that. We looked on Wolfram Alpha, and we know how to graph that. It looks like that. It looks hyperbolic, only one part of the hyperbolic function, because this always has to be positive. In other words, if it was 1 over x, we would have this also, and x could be negative or positive. But as long as it's 1 over root x, it's only that.
But I thought you said when it's a square root, it could be either positive or negative. So how do you know you only use the positive side?
Well, let's talk about that, because that is a little confusing. If I write that, I mean this. If I write that, I mean this. So if you see a radical sign and it does not have a sign in front of it, it means the positive.
Mm-hmm.
Not to be confused with solving this equation. How do you solve that equation?
You square root both sides.
So x equals what?
Plus or minus.
Square root of 4, correct?
Yeah.
Which is plus or minus 2. So if you are solving an equation, always, by taking the square root of both sides, always begin your answer with the words plus or minus, because that's correct. However, if I'm writing radical 16, that's equal to 4, not plus or minus 4.
Okay.
You see the distinction?
Mm-hmm.
Okay. And it's strictly convention. In other words, when we write radical 25, we mean the positive square root of 25. We don't mean plus or minus square root of 5. However, if I'm solving an equation and I have that, and I have to solve for x, that is plus or minus 5.
Okay.
Okay? And that's all I can say about it. In other words, we've come up with a convention where if you have the radical sign, you are assuming a plus in front of it unless otherwise specified.
Mm-hmm.
All right. So if the parent function is not in your list of parent, do you have a graph with each of those parent functions?
Yeah.
Okay. If the parent function, for example, f of x is equal to 1 over root x, that's not a parent function. That's also not a transformation of any parent function that I know of. However, one could call that a parent function. We know what it looks like. It looks like something like that, which means now we could do all kinds of transformations to that. If I want to know what this is, then I'll just move this exact curve up 3 units so that this, instead of being at 1, is now at 4, and you have a curve that is asymptotic with that.
Okay.
Okay, so we can take this new parent function, 1 over root x, and transform it however we like. I could also transform it like this, which is our original red function moved to the right by 2 units. So if I put a different color on that and graph it, it's basically that. So that the vertical asymptote would come at x equal 2 instead of x equals 0. So you can still take elementary functions and apply the 6 transformations on them that we know exist. But it doesn't necessarily have to be in your list. There are a lot more than 15 parent functions. Most of my students only get a list of about 10. When I went to list them out, I could only list like 8. The fact that you have 15 of them, that tells me that there aren't just 15. You can have all kinds of parent functions. I could have y equal to 1 over the cube root of x. That could be a parent function. And I would have to figure out how to graph that, but nonetheless, all of my transformations would apply. Do you have another one?
Yeah. I have f of x is equal.
Just 1 minute. Let me erase all this. Okay, go ahead.
F of x is equal to the absolute value of x minus 3 over x minus 3.
Like that?
Yeah.
Okay. Depending on what x is, this, once again, one of the other elementary functions is f of x equals absolute value of x. So let's take this in 2 steps, first of all. Let's assume that was the problem. Well, I know what my absolute value function looks like. That's y equal absolute value of x. What does the 3 do?
It moves it to the right 3 units.
Okay, so if I wanted to graph what I have drawn there, it does not change the shape. Anytime you have a horizontal or a vertical shift, it does not change the shape of the graph, just turns it to that. Okay, that would be a horizontal shift of 3 units, and we could handle that. Now, let's go back and look at the whole problem. with the x minus 3 in the denominator? Well, when you have an absolute value like this answer is going to be either 1 or minus 1. Can you see why? In other words, let's treat it as a piecewise function.
Okay.
So the numerator is equal to x minus 3 whenever x is greater or equal to 3, correct?
Yeah.
And the numerator is equal to minus x minus 3 whenever x is less than 3. In other words, if you make x 1, well, the numerator is becomes 1 minus 3, which is a negative 2, which becomes positive 2. Hold on here. That's not right. Okay, let's just talk about this whole function. When x minus 3, whenever x minus 3 is positive, this thing's equal to 1, correct?
Yeah.
And what makes x minus 3 positive is when x is greater than or equal to 3. Even if it's exactly equal to 3, the whole thing is equal to 1. Now let's make x a number less than 3. What if we make x 0? What's this thing equal to?
It'd be 3 over negative 3, so negative 1.
Right. What if we make x minus 10?
It'd be 7 over negative 13.
Still be minus 1. It's not 7, it would be negative 13 over 13.
Negative 13 over 13.
Yeah, but it's still minus 1. In other words, what did I say? If we make it minus 10, so I'm going to plug in minus 10 for that. And I'm going to plug in minus 10 for this. Well, that's the absolute value of minus 13, which is 13 over negative 13. So whenever x is less than 3, the function is minus 1. Whenever x is equal to or greater than 3, the function is plus 1. So if I wanted to graph that, that's what the graph's going to look like.
Okay.
Now, again, this is not a standard transformation problem. This is just something that you kind of have to notice that the graph is a piecewise graph, as it's always going to be whenever we have a transformation. If we were dealing with just the parent function of y equal absolute value of x, we could apply the 6 different transformations to it. But so far, you have not given me a single problem that we could actually apply transformations to, except for maybe the 1 over root x plus 3, because 1 over root x is an elementary function. It is a parent function. But this is not really. I have to break that down and almost graph it based on treating it as a piecewise function. And then you can see that there really isn't much transformation involved here. It's just -1 whenever x is less than 3, and it's +1 whenever x is greater than or equal to 3.
Mm-hmm.
So let's talk about, I assume it asks the same questions, domain and stuff?
Yeah.
Okay. What can x be? Or actually, domain is always about what can x not be.
So x is negative.
No, x can never be 3.
Yeah.
Because then you'd be dividing by 0. In fact, my graph here needs a open dot right there. And I need to take away that equal sign because x cannot be 3. If x were 3, I'd be dividing by 0. You can never divide by 0. And is that the only value that x can't be? Can x be negative infinity or positive infinity or negative a billion?
Yeah.
Okay, so tell me what the interval notation is for that domain.
Negative infinity, comma 3.
In union.
And then 3, comma positive infinity.
Yeah, so that is the interval notation for that answer. Now, if you look at the graph, what's the range?
-1, comma 1.
Do you see any values vertically that are between 1 and -1?
No.
No. It looks to me like y is either -1 or +1, nothing else. In other words, when I'm talking range, I'm talking f of x. And f of x is either equal to 1 or -1, but no other number.
Hmm.
Can you see that on the graph?
Yeah, it only crosses this.
So what would the interval notation of that look like?
Parentheses, or would it be bracket because you're including it?
Yeah, you're right. It should be graphic.
So it'd be -1, comma 1.
No,
and then close.
It actually cannot be between those two values. It can be -1 in union with +1. That's it. That's all the f of x can be, either -1 or 1. Can't be 1/2, can't be 0, can't be 2, can't be -2. And you can see all of that from the graph.
Oh, okay.
Okay. So I suspect that's why they're asking you these questions. What is the domain? What is the range? And graph it. Because once you graph something, you can figure out the domain and range by just reading the graph.
Yeah.
Okay. So anyway, listen, I have run a little bit late here. This was supposed to only be a half-hour session. That's fine. I don't have any problem with that. Hopefully I've helped you a little bit.
Yeah.
But more importantly, you see how this works. And I would love to work with you in the future. And I think your mom knows how to schedule appointments. And this is the way it works, okay? So hopefully I can be of assistance to you in the future.
Yeah, this is definitely helpful.
Okay, good. I'm going to go ahead and sign off now, and you should have this software here. Let me show you my desktop. If you follow my cursor, see that icon right there? It says go to me.
Yeah.
You should have that on your desktop now.
Okay.
When you
Yeah.
downloaded and installed it, it should have left that icon on your desktop. So the next time you want to have a GoToMeeting, you don't have to go to that website. You just have to double click that icon and put in the 9-digit meeting ID number that I send you. And that does change every session. Okay? So the very first thing I do when a new session is text the meeting ID number to the student. And then what you do when you get that 9-digit number is double click on that GoToMeeting icon, put it in the 9-digit number, and we're in a meeting.
Got it.
Okay?
Okay.
Subhi, good luck to you, and hope to talk to you again.
Thank you.
You're welcome. Bye-bye.
Bye.